Recording in progress. Hi students. In the last lecture, we have discussed first law, and in that we have discussed isothermal process and adiabatic process. Let us now continue. So next one, let us take isobaric process. Isobaric means pressure constant. It is isobaric process. So pressure of the gas is a constant. See from this what we can write. If we are taking gas equation, so PV equal to nRT. So when P is a constant, then we can say volume is proportional to absolute temperature, right? That means for isobaric process, if you plot a graph, volume versus temperature, it will pass through origin. So whenever we are given a graph, that is volume temperature graph, if it passes through origin, that indicates it is isobaric process. Okay. Next, coming to from first law. So Q equal to delta U plus W. And we know coming to Q value is given by, since it is now pressure constant, it is NCP delta T. It is NCP delta T. And we are knowing that delta U, it is always equal to NCV delta T. This is for any process. And coming to work done, it is integral P dV. Since pressure is a constant, we can take P outside, integration of dV. That gives us change in volume. It is directly P into delta V. Or we can write this is equal to, from gas equation, P delta V is equal to nR delta T. It is equal to nR delta T. And we have to keep one more point in mind, that is integral P dV. We are knowing that integration gives area under the graph. That means when we are taking pressure volume graph, it is also known as indicator graph. So in this volume, pressure and volume, suppose the graph is now given, let us say like this. Okay, so this is shape is, if you are taking isothermal process, it is known as a rectangular hyperbola because PV equal to constant. If you are taking now this area, that area gives work done by the gas. So area under pressure volume graph with volume axis gives work done by the gas. And when you are taking isobaric, P constant. So since P constant, it will be parallel to volume axis. Okay. That means now this is the area which gives work done by the gas. Okay. Next, focus constant volume. It is known as isochoric process. And here we can see one more point from this one. See carefully. We got a Q value NCP delta T. Delta U value NCV delta T. And W NR delta T. Substitute these values in first law, we get throughout what we can say, n gets cancelled. Remaining is Cp is equal to Cv plus R. See carefully once. throughout n delta T gets cancelled. Remaining is now Cp. Cp equal to Cv plus R, or Cp minus Cv is equal to R. Okay, right. Let us see here now. Isochoric process. Isochoric means volume is a constant. Volume is a constant. So if you are taking gas equation, PV equal to nRT. Since volume constant, N is a constant, R is a constant, therefore P proportional to T. Means if we are given graph, that is pressure versus temperature, that indicates, means if it is a passing through origin, that indicates it is isochoric. You can see here plotting a graph for what? For volume and temperature. Let us take volume versus temperature. Graph is a passing through origin, and you can see slope is giving us. See, slope gives us what from here? If you differentiate this, what we get? P dV equal to nR dt. See carefully. It is differentiating that gas equation. We get P dV is equal to nR dt. So here slope means dV by dt. Slope is dV by dt. That is now nR by P. So slope gives us, means volume temperature graph, slope gives us nR by P. Okay. If you are given two graphs for same system, okay, then what happens is nR is a constant. Then the one which has more slope, that is having less pressure. Okay. So volume temperature graph, slope gives us nR by P. In the same way, coming to here, if you are taking graph pressure versus temperature, it is a passing through origin. And see gas equation PV equal to nRT. Differentiate that. dP into V is equal to nR dt. Okay. And here slope means dP by dt. dP by dt. dP by dt equal to nR by V. So slope of pressure temperature graph gives nR by V. So slope more means its volume is less, right? So more slope, less volume. Okay. Next, coming to work done. Coming to work done, see what we can say. It is integration of P dV, but this is volume constant. That means in this no work is done. Okay. So from first law, what we can say is Q equal to delta U plus W, W 0. Therefore, Q equal to delta U. See, its meaning is the heat energy given is completely utilized to raise its internal energy of the system. I am repeating, heat energy given to system is completely utilized to raise internal energy of the system. Okay, the meaning of that. Okay, now focus. It is cyclic process. See the meaning of cyclic process. Cyclic means initial state and final state both are same. It is initial state and final state both are same. That means what we can say is delta P 0, delta V 0, delta T 0. It's the meaning of initial state that we represent with the help of pressure, volume, and temperature. Okay. So initial values and final values both are same. So delta P 0, delta V 0, delta T 0. But here we should be very careful. Delta P 0 doesn't mean that constant pressure. Delta P 0 means initial P value, final P value both are same. See carefully here. Isobaric process, P constant, that implies delta P 0. Getting the point? So here P constant, but coming to here, P is not a constant, but final pressure, initial pressure both are same. Coming to here delta V. Delta V 0, E doesn't mean that volume constant. Only initial value, final value both are same. You can see isochoric process, volume constant, that implies delta V 0. Okay, so volume constant means delta V 0. But converse need not be true. Converse means delta V 0 doesn't mean V constant. Delta V 0 means we're having two possibilities. One is V constant. Second one, initial value, final value, both are same. Okay. Next, coming to third one, delta T 0. Delta T 0 means, again, if you remember, isothermal process. In that, temperature of the system is a constant. So in for isothermal process, delta T 0. But coming to here, delta T 0 means this is only initial value and final value. That means for isothermal process, delta T 0. Delta T 0, that does not imply it is isothermal process. Delta T 0 means having two possibilities. So one is a T constant. Another one is initial value and final value both are same. Now see carefully. Delta T 0, that means delta U value 0. We are knowing that change in internal energy of the system, it is state function. It is not path function. So we have to focus what is initial temperature and what is a final temperature. It is now same. Therefore, delta U value 0. Delta U 0 means that implies from first law delta U 0. So from first law Q equal to W. So Q equal to W. Students, you should be very careful while having questions basing on theory. Like if you observe in isothermal process delta U 0, Q equal to W. Suppose the question is given like Q equal to W. So what we can say about this? Temperature constant, that is may not be correct. Q equal W means delta U 0. Delta U 0 means delta T 0. Delta T 0 means having two possibilities. Okay. Initial value, final value both are same. That is one possibility. Second possibility, constant temperature. So you should be very careful while having conceptual questions. Okay. Right. So this indicates that if W positive, Q positive, meaning is if we provide energy to system, work done will be positive. If you are taking energy from system, work done will be negative. Remember, W always stands for work done by the system. Okay. Now see graphs. Suppose having a graph like this, pressure versus volume. Suppose graph is given like this. Okay. Starting point is A. Again, end point also A. Okay. Starting point and end point both are A only. Let us take it is now anti-clockwise. So now question is here, is the work done by system positive or negative? Okay, so we should be very careful here while calculating work done. Let us take here one more point, that is B, diametrically opposite. If you observe carefully from A to B, volume increasing, therefore work done by the gas from A to B will be, that is now area under the graph. This is work done by the system from A to B. Okay. Now if you observe from B to A, B to A volume is now decreasing. That means by the system negative work is done. By the system negative work is done. And that work is given by area under the graph from B to A. That means it is entire graph, it is completely. So when you are taking complete one, you can see the overlapped region. That is nothing but A to B, right? Below this one. This green part and yellow part, both will cancel because one is a plus and one is minus. Remaining is now only the area confined to this part inside the graph. Okay. That means net value is now negative. So how to say that? If it is anti-clockwise, work done is negative. If it is anti-clockwise, work done is negative. If it is a clockwise, if it is clockwise, work done will be positive. Okay, see carefully. So when you are taking cyclic process, delta U value 0. So Q equal to W. How to calculate W means simply focus now area under the graph. If it is anti-clockwise, work done by system is negative. Clockwise, work done by gas is positive. Okay. Let us now focus free expansion. Right. Let us focus now free expansion. See what is the meaning of that? Consider a vessel which is, you can say, insulator. It is an insulator, or you can say non-conductor. Now some part of this is now vacuum. Let us take into two parts. This is vacuum and this is now gas. And if there is a one valve is here, there is a one valve. Okay. So here condition is we are taking it as a non-conducting vessel. Having here two parts. One is gas, other one is vacuum. And once we are opening this valve, gas expands and occupying the entire volume. And in this process, it is observed that delta T equal to 0. So delta T 0 means delta U value 0, right? Delta U value 0. And if you are taking first law, Q equal to delta U plus W. Now here, since it is vacuum, there is no pressure. When there is no pressure, no work is done. We should be very careful here. While calculating work done, we are taking that integral P dV, right? When there is no pressure here, no work is done. That means W equal to 0, right? W 0, delta U 0, that implies Q equal to 0. In fact, this is already known, right? Already we have taken condition that it is non-conducting one. So from system, no heat is taken, no heat is given. Already Q is 0. Getting the point. Already Q is 0, delta U 0, therefore W is 0. But we can do one thing, don't take this conclusion here. It is not implying Q 0. See carefully once. First, we observe that delta T 0, therefore delta U 0, delta U 0. Since it is now non-conducting, no heat is given to system, no heat is taken from system. So Q 0, Q 0, delta U 0. Therefore, that implies W is 0. So W 0, delta U 0 and Q 0. This is known as a free expansion. Okay. Let us now focus polytropic process, the last one. See, polytropic process is nothing but it is a general process. See what we are writing here. For polytropic process. So we are taking the condition that PV power x equal to constant. What is it? PV power x equal to constant. And in that, if you observe, taking x value 1, that becomes PV equal to constant. That means it refers to isothermal process x equal to 1. If you take x equal to gamma, so PV power gamma equal to constant, right? That represents it is adiabatic process, right? If I am taking x value 0, so V power 0 means it is 1. So P equal to constant. It represents isobaric process. So it is now some general process. It depends on the value of x, right? And see how to calculate work done. If you remember, while discussing adiabatic process, what we got? Exactly same thing. The only change is now in the place of gamma taking it is x. That means in this process, work done is equal to, we got there 1 by 1 minus gamma, it is 1 by 1 minus x into P2V2 minus P1V1. So we are taking as it is what we have discussed in adiabatic process. Okay. Just take in the place of gamma it is x, or writing same thing as it is nr delta t upon 1 minus x. Okay. Now take this one in first law. First law Q equal to delta U plus W. In the place of Q, it is NC delta T. What is it? NC delta T. Delta U. It is always equal to NCV delta T. Always. Plus, in the place of work done, NR delta T upon 1 minus x. Okay. Now simplify this. n dt gets cancelled. So C equal to CV plus R by 1 minus X. So keep this result in mind. We use it frequently while solving problems. So for a polytropic process, C equal to, for a polytropic process, C equal to CV plus R by 1 minus X. Okay. So in the next lecture, we can discuss problems based on all these processes.